Okay, you guys are going to do an aluminum foil lab, or you've already done it. I'm not sure how it's going to work out. And it's a very easy lab to do. You're instructed in the lab to go and get 20 pieces of aluminum shot, and just put them on the pan of a balance and weigh it. And now this, I'm going to make up some fictitious data so that you guys can, so we can talk about how to write this up. So I put 20 pieces of aluminum shot on the balance, and it weighed 9.28 grams. Now I don't want you to put grams over here. The grams is over here. Then you get a 25 mil graduated cylinder. Okay, and so this is my bad picture, and you're supposed to put in exactly 10 milliliters of water, and then you drop those 20 pieces in into the water, and my water went up to 13.4 milliliters. Now remember, our graduated cylinders have a marking at like 10, and they have a marking at 12, and they have a marking at 14, and they don't have a marking at 11 or 13, but there's a line there. And then in between each, 10, 11, 12, 13, there's 5 lines. So what you have to know is each line is 0.2. So your volume should be written, should end in 0.2, 0.4, 0.6, 0.8, or 0.0. So if your meniscus hits right, the meniscus hits right here, exactly on the 11, you write 11.0. But if it's down here and it's hitting on this, not this big line, but the line 4 is up, that would be not 11, but 10.8. Okay, so what's the volume of aluminum shot? Well, the water was 10. After you put the aluminum in there, it pushes the water up to 13.4, so the volume is 3.4. Then you're supposed to take a piece of aluminum and cut it 12 centimeters by 12 centimeters and weigh it. And when I did that, by the way, this is fictitious data, it was 0.66 grams. Now on your lab, there's a big giant fat line. Sorry, the big giant fat line is here, because anything, yeah, I'm having a terrible time drawing today. Let me grab this eraser. Um, where is my eraser? Right there. So on your lab, you have a big giant fat line. Um, I'll go back, grab a pen, maybe switch to black. Right here, there's a big giant thick line, and that's supposed to indicate that everything underneath here is not data but a calculation. And so then you guys have 4 calculations to do, and I'm just going to take you through each one. First question is determine the density of the aluminum shot and record the result on the data table. Show all work before. So for me, I would say, okay, determine the density. I want to know density. The density of the aluminum shot is the mass of the aluminum shot divided by the volume of the aluminum shot. So I go back to my table. Mass of aluminum shot is 9.28 grams. So I'm going to go down here and I'm going to write that the mass is 9.28 grams and the volume is 3.4 milliliters. Where did I get that? Again, they said the mass of the aluminum shot is 9.28 grams. The volume of the aluminum shot is 3.4 milliliters. So then I go back to my calculation page. Now remember, when you guys took the test, you always have to have the formula, density is mass over volume, then you have to plug in numbers with units. And then the calculator will say, because I was putzing this out, my calculator says, oops, I don't have this one, so let me do this. 9.28 divided by 3.4. The calculator says 2.729411765 grams per milliliter, but I do not get 9 sig figs. 9.28 has 3, 3.4 has 2. This needs to be rounded to 2 sig figs. The density of the aluminum foil is 2.7 grams per milliliter. Now, I just want to show you one tricky thing that's going to matter in a minute. If you look on the sheet, They want the density of aluminum in grams per cubic centimeter, not in grams per milliliter. But the reason why that isn't an issue is, if you remember from last chapter, okay, I really hate black pens. I'm going to go to blue pens because we go to tartan. 1 milliliter is equivalent to 1 cubic centimeter. So 2.7 grams per uh, milliliter is 2.7 grams per cubic centimeter. And so then it says record the result on the data table. So we're going to go back to the data table, and what goes here is 2.7. I do not have to do anything else. Okay, second one. Then if you go to the second question, find the volume of the aluminum foil by using the equation, and the equation's not there. It's on your sheet, but it's not on my PowerPoint. And show the work below. And so they want the volume of the aluminum foil. Now, not the aluminum shot, the aluminum foil. So volume is mass over density, because remember the density triangle? Density is mass over volume. If you're solving for volume, you put your big old fat hand over the V, and the formula says mass on top of density. Now, but that's neither here nor there because I gave you the formula. So what is the mass of the aluminum foil? Oops, sorry, I'm going blue. Go back. What is the mass of the aluminum foil? For me, it's 0.66. You use whatever yours is. I have 0.66 grams divided by the density of aluminum, which we just calculated. It's your answer for question 1. This is whatever answer you got for question 1. You're probably going to get a different one. Now remember, this is bad notation, so we're going to go 0.66 grams. So you leave the top alone, and then the bottom it gets flipped. It's 1 cubic centimeter over 2.7 grams. Grams cancels grams. When I do 0.66 divided by 2.7, my calculator says 0.244444444. Can't be obnoxious. Cubic centimeters. Remember the rule. Formula, plug in numbers with units. 0.66 is a number, grams is a unit. This is bad form. It's a complex fraction. You leave the top alone. You change this division bar to multiplication and do the reciprocal. Because this has 2 sig figs and this has 2 sig figs, we get 2 sig figs. So this is 0.2 cubic centimeter. And then again, it says record the result on your data table. You go back up to your data table, and the volume of the aluminum foil is 0.24. By the way, this is the answer for calculation 1. This is the answer for calculation 2. Please do not have this in your lab report. Only numbers in your lab report. Okay, find the height of the aluminum foil. Now, I like this. Volume equals length times width times height. And the question is, what's the height? Now, remember the rule in chemistry is you have to do the algebra first. So length times width times height. If I want to get height alone, I have to divide by length times width, because this cancels this and this cancels this. It's just that we have this rule in algebra that, sorry, this is not length times width. There's this rule, the rule in chemistry is you can't use the factor label method. You have to do the algebra first before you plug stuff in. Now I'm going to erase that because I just wanted you to see where I got that equation. I'm going to erase this and start over again. So if you'll notice, the problem says find the height. The unknown is the height. The formula for height is volume over length times width. Now, our volume is 0.24 cubic centimeters. We just solved for that in question 2. Okay. Now, what's the length and the width of the aluminum foil? You were instructed to cut it 12 centimeters by 12 centimeters. And again, this is not leading to an improper fraction. This is 0.24 cubic centimeters. And then 12.0 times 12.0 is 144. This has 3 sig figs. This has 3 sig figs. 144 has 3 sig figs. A centimeter times a centimeter is a square centimeter. When I do 0.24 divided by 144, and then I have a cubic centimeter over a square centimeter, when I do this on my calculator, I get this very, very tiny answer called 0.001666667 centimeters. Because if x squared cubed over x squared in your math class is x, then a centimeter cubed over a centimeter squared is a centimeter. And why is that important? Because you would expect that height would be have centimeters. Now, but you always have to worry about sig figs. And this one's kind of crazy because um, when you go to do the sig figs, these first two zeros don't count because they're not final zeros and they're not sandwiched. And so the height of the aluminum foil in centimeters is 0.0017 centimeters. You could not measure, so you got this piece of gold foil. It's really, or it's not gold foil, sorry, I'm thinking of the Rutherford gold foil. Aluminum foil, it's really, really thin. It's too thin to measure with a ruler. And so now I go to the data table because it always says record the result on the data table. And so the height of the aluminum foil is 0.0017. And this is your answer for calculation 3. And I don't want to see this stuff on your lab report. I'm just trying to tell you. And then so we wanted the height of the aluminum foil in centimeters, and we wanted the thickness of the aluminum foil in atoms. This is the trickiest question right here. The diameter of an aluminum atom is 2.5 times 10 to the negative 8 centimeters. Find the thickness of the aluminum foil and record the result on the data table. Show all work below and use the factor label method. Hint, one atom is 2. So here's the deal. We need to think of it like this. Here's an aluminum atom, it's round, and here's an aluminum atom, it's round, and here's an aluminum atom, it's round, and here's an aluminum atom. And notice that's a diameter, and that's a diameter, and that's a diameter, and that's a diameter. And the question is, if the diameter of each of these atoms is 2.5 times 10 to the negative 8 centimeters, how many of these circles would you have to have stacked on top of each other to get a height of 0.0017 centimeters, if that's your number? You might have a different number. That's just my number. And so again, I'm going to erase this. And all this is the factor label method. There's no formula here. But I gave you the conversion factor because this is what you do. You take your answer from question 3, which was 0.0017 centimeters. That's how thick the aluminum foil is. And then the conversion factor is one atom is 2.5 times 10 to the negative 8 centimeters, but centimeters on the top. So 2.5 times 10 to the negative 8 centimeters goes down, and one atom goes up. This cancels this, and when I do this on my calculator, I get 68,000 atoms. Think about that. There are 68,000 aluminum atoms stuck on top of each other to get that thin little thickness of aluminum foil. And so, but now here's the tricky part. This has 2 sig figs and this has 2 sig figs. And if you're unlucky, and your answer comes out to be like 60,000 or 80,000 or 90,000 or 100,000 or 110,000. Actually, 110,000 is fine because it does have 2 sig figs. Here's the deal. This has 1 sig fig because rule 1, that's a final 0, but it's before the decimal point. They aren't sandwiched. If I do this, all of a sudden, this is rule 2. These are sandwiched. Now it has 1, 2, 3, 4, 5, 6. So what I just want to say here is if you're unlucky and you end 60,000, 70,000, 80,000, 90,000, 100,000, you have to put it in scientific notation to get 2 sig figs. So you would just go 1, 2, 3, 4. This is 6.0 because now times 10 to the 4th. And now this rule one, that's a final zero after the decimal point. If you get 80,000, it'd be 8.0 times 10 to the fourth. If you get 90,000, it's 9.0 times 10 to the fourth. If you get 100,000, 1, 2, 3, 4, 5, it's 1.0 times 10 to the fifth. So be careful. Now, if you get 62,000 or 72,000, whatever, 1, 2, you're done. It has to. Okay, record that on your data table. So I'm going to go back to the data table, and my answer right here is 68,000. Now, because notice 68,000 atoms, 0.001 centimeters thick. The volume is 0.24 cubic centimeters. By the way, when you have a square piece of aluminum foil, and this is 12, and this is 12, we think of this like a Kleenex box, where the volume is length times width times height, and the length and the width are 12, but the height, it's a tiny little thickness, the height of the foil. All right, last thing I gotta tell you is we're done writing conclusions, but here's the deal. In the conclusion, you have to remember, if you have a two-sentence purpose, you need a two-sentence conclusion. The way that the purpose is written, this is confusing. The way that the purpose is written is this: to determine the density of aluminum and to compute the thickness of aluminum foil. Now, because I use the word thickness and not height, I want you to report the density of aluminum, that's this number, and the thickness of aluminum foil, that's this number. If I wanted the height of the aluminum foil, I would have said to compute the height of aluminum foil. So I'm going to do this verbally because we're done writing them. To changes to we, determine changes to determined. We determined the density of aluminum, comma, and we found it was 2.7 grams per cubic centimeter, period. That's mine, because we determined the density of aluminum and we found it was 2.7 grams per cubic centimeter. Then the next sentence, right next to it, don't separate them. We determined the thickness of aluminum foil and we found that it was 68,000 atoms thick. Thickness of aluminum foil, 68,000 atoms. Okay, when you turn in your lab report, just remember that all you should have is these numbers, none of this. So you should have 2.7, 0.24, whatever. You got to use your own data. This is my data. By the way, this is not accurate data. So just use your own data. All right, enough said.